In the previous videos, we have seen what is a deterministic finite automata. Now, in this video, we are going to watch what is a non-deterministic finite automata and what is the formal definition of non-deterministic finite automata. Non-deterministic finite automata and deterministic finite automata both have the same power. But when it comes to the construction of DFA and NFA, NFA is somewhat easy compared to the DFA. So here, if you see the definition of deterministic and non-deterministic, what makes the difference between deterministic and non-deterministic? In non-deterministic, one state on one input symbol, there is a chance of transitions to more than one state. That means on the present state with the present input symbol, there may be a chance of transforming to more than one state. That means this is non-determinism. You cannot say directly that you are going to one state like in DFA. In DFA, on one state, on one input symbol, we are directly going to another state. There is no confusion. But in non-deterministic finite automata, on one state with one input symbol, we may go to more than one other states. That is called as non-determinism. Simply we can say that there is a confusion in changing one state to the more than one state. And that means you cannot clearly say we are going to this state only. You are going to more than one state. Suppose if you see, suppose here you have a state Q0. You have a state Q0. On Q0, on taking some input A, you are going to Q1. At the same time, on the input symbol A, you are going to Q2 also. That means on the same state, with the same input symbol, you are going to more than one state. This is one state, this is one state. So that means non-determinism. You cannot clearly say that you are 100% confidently going to the Q1 only, or you are 100% confidently going to the Q2 only. You have two states. That means you are traveling from the current state with the same input symbol to more than one states. This is called as non-determinism. But when it comes to the deterministic finite automata, on one state, on one input symbol, you are simply going to only one state. There is no confusion. It is determinism. But if you go for more than one state of the same input symbol from the current state, then it is called as non-deterministic finite automata. If you see the definition of non-deterministic finite automata, we can call NFA or NDFA, non-deterministic finite automata, or simply NFA, non-deterministic finite automata. You can write like this also or like this also. You can see the definition. Non-deterministic finite automata is an automata in which for some current state and input symbol, there exists more than one state outputs. That means you are going to more than one states from the current input symbol and the current state. So this is known as non-deterministic finite acceptor. This is also known as a non-deterministic finite acceptor. So here we will see some points about what is a non-deterministic finite automata. So NFA stands for non-deterministic finite automata. It is easy to construct NFA than DFA because DFA is very constrained on one input symbol, on one state. You have to go exactly only one state. But there is a flexibility given in non-deterministic finite automata. So a flexibility is given in the non-deterministic finite automata. So because of that, NFA is somewhat easy compared to DFA. So it is easy to construct an NFA than DFA for a given regular language. The finite automata are called NFA when there exist many paths for the specific input from the current state to the next state. That is what is called non-determinism. There exist many paths from the current input symbol, from the current state to the next state. Every NFA is not DFA, but so each NFA can be converted into DFA. Every NFA is not a DFA, but that means each NFA can be converted into a particular equivalent DFA. NFA and DFA both are same in the will be defined in the same way, but with small differentiations. One is NFA contains multiple next states on the same input symbol, and it contains sometimes epsilon transitions also. Sometimes without any input symbols also we can move from one state to the another state. So that we will call it as a NFA with epsilon moves. So right now we will discussing about only NFA without any epsilon. So NFA means non-deterministic finite automata in which you have more than one state from the current state. Suppose if you see the following example, here Q0 is your initial state. Q0, B and Q0 you are going to B only. If you take A on Q0, you are going to Q1. You are going to Q1. At the same time, A on Q0, you are going to Q2 also. Next one, on taking B Q0, you are going to Q1. That means on current state Q0 with B as input, you are going to Q0. At the same time, you are going to Q1. Similarly, on current state Q0 with the input symbol A, you are going to Q1 and also you are going to Q2. That means on Q0 with symbol A, you are going to Q1 and Q2. That means you have two states. Similarly, on input symbol B, you are going to Q0. At the same time, you are going to Q1 also. This is what is called non-determinism. So this is the diagram of what is a non-deterministic finite automata. That means it is not fixed or determined that with a particular input where to go next. You don't have clarity whether to go this side or this side. That means with a particular input you don't have any fixation that you will go to a particular state. So that means there is no clarity. That means there is some confusion is there in which state you are going to the next one. That what is called non-deterministic finite automata. So this is just introduction of definition of what is a non-deterministic finite automata. Now we will see actual definition of formal definition of an NFA. So if you see the formal definition of an NFA, NFA is also an automata. It can be defined as a phi tuple. It can be defined as a phi tuple. Non-deterministic finite automata is a machine which can be defined with a phi tuple Q, sigma, delta, Q0, F, like an DFA. The only difference is in the transition, in the definition of transition function. Here Q is a set of states defined in the machine. What are the finite set of states defined in the Q? They are called as Q. Similarly, sigma is a non-empty finite set of symbols called input alphabets. So definitely you have some string of input alphabets. So sigma is an input alphabet. Now the definition of delta will be changed. In DFA, on one state with one input symbol, you are going to only one state in the Q. But when it comes to the NFA, you take one state from Q and one input symbol from sigma, you are going to 2 power Q states. That means any possible 2 power Q states you are going to. That means from Q, how many possible states you can go? You can go 2 power Q states. So that's what makes the definition of transition function from NFA to DFA. In DFA, you have clarity on one input symbol, on one state, you are going to only one state. But when it comes to the NFA, from one of the states in Q and one of the input symbols in sigma, you are going to any possible 2 power Q states. So that makes the difference between what is an DFA and NFA. So here Q maps Q cross sigma to 2 power Q states is a total function called a transition function in NFA. Now Q naught. What is Q naught? Q naught is an initial state. Q naught is an initial state. What is F? F is a set of final states which are subset to Q. That means the finite states also, the final states also are taken from your Q only. We are taking the final states from Q only. So F is subset or equal to Q. That means you may have one final state or more than one final state. Whatever it may be, the final states also coming from Q only. So the final state set is subset or equal to Q. So this is what about the definition of NFA. So only one thing we have to keep in mind, that an NFA is an easy way of designing the problem. That means if you have any problem, when it compares to the DFA, it is easy to convert an NFA. Again, if you want to convert each NFA into DFA, again we have a mechanism called equivalence of NFA and DFA. With that mechanism, we can convert an NFA into a equivalent DFA. So that we will see in the next videos. So here in this video, I have explained clearly the definition of NFA. In the next videos, I will take some examples and I will explain you how to construct the NFA. So thank you for watching this video. Thank you all. Thank you for watching this video. If you really like this video, please subscribe, like, share, comment on my YouTube channel. In future, we are going to create many more videos on computer science engineering subjects. Thank you.